Hey everyone, so today we're starting section 3.1, and what I want you to do quickly is your warm-up exercises. It says evaluate without using a calculator. So just solve for the square root of 121 and also 5 raised to the negative squared power. We'll go over those when we come to class next. Example 1. We're talking about nth roots today. So we talk about square roots a lot, which is just taking a number and multiplying it by itself to get a perfect square. It's kind of the opposite, right? We're dividing a number by a factor that is equal to its factor pair. So for example, 9 would have a square root of 3, or 25 has a square root of 5. So we're looking at thinking about the nth roots of a situation. So I know that when I'm looking at these examples, I'm going to think about what is the number that I'm looking at, which in this case is negative 216, and what is the root. So I'm looking for the cubed root of 216. The other way that I can write this is negative 216 raised to the 1/3 power. That also represents the root rather than an exponent, if that makes sense. So when I look at this number, negative 216, I want to know there's a value that when it's multiplied by itself 3 times, it's going to equal 216. I kind of try to use my background knowledge when I think about this, because I know, for example, that the number 5 times 5 is 25, and then that number times 5 is 125. So that's less than 216. So I'm going to increase from there. So I can say 6 times 6 is equal to 36. And if I take that number and I multiply it by 6 again, I actually do get 216. But I'm looking for a negative 216. So my cubed root should be negative 6, because a negative times a negative would equal a positive, and then that positive times a negative would then equal the negative that I'm looking for. So the cubed root of negative 216 is actually negative 6. Part B says, what is the 4th root of 81, or what is 81 to the 1/4 power? Now again, I'm going to start with smaller numbers that I think will work. So I would start with maybe the number 3. 3 times 3 is 9, times 3 is 27. Which times 3 is equal to 81. Wow, that was pretty good. I got that on the first try. So I know that the 4th root of 81 is going to be equal to 3, right? If I had started at the value 2, I would have said 2 times 2 is 4, times 2 is 8, times 2 is 16, and that would have been too small. It's not equal to 81, so I would have known that I had to keep moving upwards in my calculations. Example 2 says evaluate 16 to the 3/2 and 32 to the negative 3/5. So let's look at these slightly different examples. 16 to the 3/2, I'm actually going to break up into a couple of components based on what I know about exponents. So I know that when I have nested parentheses, that is here, and I multiply exponents together, I get an original exponent. So I also know that 1/2 is the same as 16, the square root of 16, right? When I was looking at my notation before, I said I could have a cubed root, or I can have to the 1/3. So I'm going to use that rule, and I'm going to think to myself, okay, if I have 1/2, 1/2 times what would give me 3/2? Well, 1/2 times 3. So now I have the square root of 16 raised to the third power. Well, I know what the square root of 16 is. It's 4, right? So 4 raised to the third power is 4 times 4 times 4, which is equal to 64. And that's it. That's my solution. So really breaking down that fractional exponent gives me a good sense of what I need to do in this particular problem. Part B is a little different, 32 to the negative 3/5 power. Now, we know that there's a rule about negative exponents that they can't be negative. So we have to put this in the denominator in order to turn it into a positive exponent. So instead of negative 3/5, it's now positive 3/5. And then I'm going to do the same thing I did before. I'm going to break this up into 32 to the 1/5 power times 3 would give me 3/5, right? And that's so that I know I could take 1 over the 5th root of 32 and then cube that value. So the 5th root of 32, I think it's going to be 2 because that's kind of a small number. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Perfect. So the 5th root of 32 is 2, and when I cube that, I get 1/8. So that helps to kind of break apart different fractional exponents for you. Moving on to example 3, this is a pretty straightforward issue. Whenever you're approximating roots with a calculator, you just want to make sure that you're typing in the caret key and keeping the whole fractional root in one set of parentheses before you hit enter. So take a second if you have a graphing calculator at home to type in these problems and make sure that you're getting the right solution in your display. Example 4 says to solve the equation. And this is pretty straightforward when you think about it. This is really basic algebra 1. We're just going step by step, and we're also going to account for the new exponent. So in this case, I want to divide both sides of my equation by 4 so that I get x to the 5th is equal to 32. And then just like you would in a typical algebraic expression, I need to take the 5th root of both sides in order to get x is equal to the 5th root of 32, which I solved for in my last problem, so I know it's equal to 2. Similar scenario, part B, because I have these parentheses, first I need to take the 4th root of both sides. So the 4th root is x minus 3 equals the 4th root of 21. I'm not sure if the 4th root of 21 is an actual whole number, right? I just got the 5th root of 2 is 32. So I'm not sure if that's actually going to work specifically for me. So this might be something I need to use a calculator for, but I can add 3 to both sides and get x is equal to the 4th root of 21 and then plus 3. So if I needed to plug this part of my expression into the calculator, I could, and that would give me an x of approximately 5.14 or 0.86. And I just did that by plugging in the 4th root of 21 plus 3. You can also plug in 21 raised to the 1/4 plus 3, and that would give you that solution as well. We're skipping example 5 for today, but I do want you to do the homework quiz quickly on your own. Find the nth root of A if n equals 4 and A equals 10,000, and also evaluate the expression without using a calculator. Remember, break up those components and use those tools that I showed you in examples 2 and 4.